say exactly how many components the overhead view was broken down into? How many, how many individual snapshots were
How many
analyzed?
total pixels? Yeah, we know that we have the scanner that we had the negative scanned with has 5,000 dots per inch. Does this answer you, or we need some more?
I guess if we were to describe, as you looked at the overhead, the computer generated overhead view.
Yeah.
How many puzzle pieces were you able to cut that up into?
Pixels, maybe
examine?
pixels per Abdelkader. You know, the top of your head, the number of pixels per unit has to be calculated. Yeah. Huh?
No, he's asking about in that breakdown diagram. You had
Units.
several sections.
Yeah.
Sections of the mall. How
Yeah.
many sections of the mall did you add together?
No. Are you talking about that? The mall sections?
Not just sections of the mall, but
Yeah.
sections of each section. Or it sounds like what you did was look at.
You put a grid. The grid was every 50 meters on the whole mall. Wasn't that, Magali?
So
It was 50 meters.
50 meters squared.
50, yeah.
So
50 meters square.
If we divided the figure 265,000 square meters by 50 meters squared, that would be the number of individual
units on the mall.
that were analyzed.
Yes, sir. Yeah. Yes, sir.
What did you take as your outer boundaries for defining the crowd? I gather that in this count you included Constitution Avenue
Yes.
and the avenue on the other side,
No, Independence.
Parallel.
Independence.
Independence.
No, we did not. We did not we did not take Independence, and we did not take Pennsylvania, because at that time there were very few people there. They could be counted in the hundreds in each block, so we knew that they were not going to change the total number drastically.
Okay, but did you look at those areas and look up the side streets a little ways?
In
away from
as
mall?
far as we could, because in these views, the oblique views, they were mostly hidden. Yeah.
And you didn't detect any excess crowding compared to a normal Monday?
On the other
On the
streets.
side streets and the areas?
I can't even comment on that because of the fact that I have no idea what do you mean by excess over the normal. So we measured the number of people from 3:15 to 3:30.
We can take a few more questions, but in the interest of the television folks who might need to make a feedback by noon, if there are any of the television people who need to ask one more question now, then we'll let you break. As I say, Dr. El-Baz can remain available.
Yeah, go ahead. Sure.
In your decision to use the Park Service images as opposed to the ABC footage,
Yeah.
didn't you compromise to a certain extent image quality? Because I'm sure the videotape shot by ABC was probably broadcast
No,
quality
sir.
videotape.
The 35 millimeter film will be better than videotape anytime.
Oh, well, then let me clarify. The Park Service actually shot 35 millimeter original?
Oh,
or
that's
they
what we
shot
had,
videotape?
originals.
Oh.
Yeah, no, the Parks, that's important. The Park Service estimation was based on their own videotape, prints from their own videotape. They had to do it fast. They did not wait to process their own 35 millimeter film, and we used their own 35 millimeter film.
So you were using original
Absolutely.
35 millimeter?
Absolutely.
Thank you.
My staff would be happy to take people inside the room and show you the computers and show you examples of these things. Thank you.
Okay, I can walk you with what I did, at least for this part. For example, these calculations. Basically, this is the image from the Park Service, and it's, as you can see, it's an oblique image. And we couldn't really estimate the crowd or do the analysis that Dr. Farouk was suggesting, which is basically 1 meter square per 6 persons per 1 meter square, because we don't know what a meter square here, and because the scale changes due to the tilt of the aircraft. So we have to correct this image to a nadir one, which is basically one taken directly from overhead. And here, each pixel in this image represents exactly 1 meter square. So what we basically do is try to register this image into the nadir one, so that at the end, we'll be tilting this image as if it has been photographed from the top, from directly above. And this, we use these control points to tie the image, which is basically we're telling the computers that this point is exactly this point. So when you do the transformation, you put it exactly on top. and so forth. So I will show you a quick demo here of a transformation that I have applied to this image. Now, this is this image, but it has been, tilted to look as if it's being viewed from directly vertical. Then the next step would be to, as Dr. Farouk was talking, to estimate the crowd density, because now we know that each pixel in this image is exactly 1 meter square, so we know how much a meter square can hold number of people. These are really sparse areas. These are highly crowded. These are something medium. This is, higher medium and so forth. So what we did is basically segmented or divided the image into different parts. The red is highly dense area where people are highly packed, and each pixel here represents 6 meters. Each pixel is 1 meter square, and per meter square we have 6 people. Here it's 4 people per meter square, so it's less, and this is even lesser. And here, as you remember here from this picture, people are very scattered around. They are not heavily packed as here, so we estimated this density here as 1 person in every 10 meters square. So adding up all these together, we came up with the number of people that were in this part of the block, which ended up to be like 266,000 people. And this is expected because this is, where the speakers are. And the procedure was followed all the way up to the monument, Washington Monument. And the final number was just basic addition of this and this and this until all the way back.
For counting people, you go and choose a person, you click on it, then you zoom it twice time, 4 times. Sometimes you are not sure, 8 times or 16 times, until you make sure that this is a person and this is the shadow. So you go and you click it and you make a cross on it. So by this cross, the computer counts how many crosses I have here. That indicate how many people I have in this area.
So, sorry, where's the count of
Here.
the number?
The computer counts the points, how many points we have in this area. By each cross I add, the computer counts with me.
Okay, so 2,473 is
No,
then
seven-
divided by something?
No, it's the actual amount of the people, because I choose every person by a point.
Oh, but that's
Individuals.
that's going 2473 up several screens from that.
Yeah.
Okay. Because it only looks like there are about I don't know,
No,
20
you
or
can-
25 people there.
Here.
So 2,473 in that.
In this area.
The grid that we used to actually have an aerial estimate of how many people fit into a unit area. In this case, this grid is, each cell is 50 meters by 50 meters. And you can see it's sort of distorted. This grid was designed basically on ortho photograph, a vertically taken photograph. The one that Dr. El-Baz showed you, which has basically 1 meter resolution, 1 pixel is 1 meter. Then we draw on, using that as a background, we draw a grid with a specified mesh size, and then we registered or rectified that grid according to this perspective view of oblique view of the photograph. So this allows us basically to say that within any cell, we can basically plot in or give a density value and say, let's say here, I don't know, let's say this is 4 people per square meters, and then all you do is you basically label each box or each cell, and you put in a number, a density number, and then you can estimate, because you know the area, you can estimate, actually how many people are there.
The per square meter multiplied
Yes.
by 25.
Exactly. But what is important is to have a grid that, you know, it would be, the ideal situation would be to have a photograph that was taken vertically. Since that's not the case, you have basically to convert or transform the grid in such a way that it fits into the perspective view of the photograph. And we did that for the entire mall. You will see that the grid looks always different. You see? Here it's sort of...